Ladies and gentlemen, annually, Malaysia produces approximately 8.3 million tons of industrial waste, which consist of hazardous materials and heavy metals. These wastes are non-biodegradable and tend to accumulate in the soil. Wouldn't it be a great idea if we could convert the industrial solid waste to value-added materials? Okay, let's just hold this thought first and let's talk about graphene. Graphene is a two-dimensional structure which looks like honeycomb, as I have portrayed in the background of my slides. It has some amazing properties whereby it has a high potential to be used as an energy storage device, which is also known as a power bank. It can also be used for water desalination, in which graphene works as a filter, and it is widely used in the semiconductor industry due to its high electrical conductivity. Now, you must be wondering, how is graphene and industrial waste interrelated? Well, my research is to carry out simulation and modeling on the synthesis of graphene from industrial waste. Now let's talk about the methodology of this research. The first step would be to carry out a process called acid leaching. Let's imagine a jungle. When it rains in the jungle, the water from the rain seeps into the ground and interacts with the surfaces of the materials. It helps transport chemical compounds through the rocks and soil. So, similarly, hydrochloric acid leaching is used to extract graphene from the metal waste. Once the residue is washed and filtered, it is then dried in the oven. Next, response surface methodology. Response surface methodology is used to carry out the modeling. Let's say we have four variables, namely A, B, C, and D. Variable A, which is the concentration of hydrochloric acid, B, the temperature, C, the solid to liquid ratio, and lastly D, the leaching time. The range value that I want for A is between 10 to 20. So this software will carry out the experimental runs and will provide the results based on the range values that you want. Next, based on the data produced, an ANOVA model can be formed. An ANOVA model is basically a quadratic equation formed by analyzing the experimental data. And for our last step, which is our simulation, the simulation is done via a software called MATLAB with the help of the ANOVA model. This software is used to obtain the maximum yield of graphene with the help of simulation based on the selected parameters. I hope this developed model will be used for the extraction of graphene from industrial waste at a larger scale, so that the industrial waste can actually be put to good use instead of causing harm to the environment. That's all from me. Thank you.